When an object such as a candle or wood burns, it produces light through a process known as incandescence. How does this relate to fireflies? And how does fireflies relate to algorithms? That's what we'll be finding out in this video, my friend. Incandescence is the emission of electromagnetic radiation, including visible light, from a hot body as a result of its high temperature. Light can be produced in a number of ways: incandescence as described above, or luminescence. The kind of light produced by the species of the Lampridae family, example fireflies, is luminescent, that is cold light. The Lampridae family are renowned for their bioluminescent capabilities, which allow them to produce light through a chemical reaction within their body. The word bioluminescent is coined from two Greek words: the Greek word bios, meaning living, and the Latin word lumen, meaning light. One of the earliest mention of the fireflies in history dates back to Aristotle. Aristotle was the first to record detailed observations and to recognize the self-luminosity of bioluminescent organisms and the property that it was not accompanied by heat, contrasting with the light from a candle flame. How do fireflies communicate? There are about 2,000 firefly species, and most of them produce short rhythmic flashes by bioluminescence. The bioluminescent light in fireflies serves two main purposes: one, attracting mates, that is communicating, and two, attracting potential prey, that is hunting. Fireflies communicate with potential mates through flashing patterns of light. Females respond to males' unique patterns of flashing in the same species, whereas in species like Photorus, female fireflies take advantage of bioluminescent courtship signals. They imitate the mating flashes of different species to attract and consume male fireflies and mistake the signals as a potential mate. Flashing rhythm and timing can vary from species to species, and as such, synchronization can occur, leading to self-organized behavior. The inverse square law of light was first postulated by John of Dumbarton, a member of the Dumbarton village community in Gloucestershire, a southwestern county in England. John of Dumbarton is recorded to have become a fellow at Merton College, Oxford, and to have studied with the likes of William Heytesbury, Thomas Bradwardine, and Richard Swineshead. These four Merton calculators were not only well versed in the current issues of philosophy during the 14th century, they actually initiated new groundbreaking scientific postulations. Dumbarton was one of the first to express functional relationships in graphical form. He gave a proof of the mean speed theorem, stating that the latitude of a uniformly deformed movement corresponds to the degree of the midpoint. He then used this method to study the quantitative decrease in the intensity of illumination, stating that it was not linearly proportional to the distance. However, he was unable to expose the inverse square law, which was postponed nearly 250 years until it was discovered by Johannes Kepler in 1604. The inverse square law of light states that the intensity of the light decreases with the square of the distance from the light source. Since fireflies are luminous in nature, they will be subject to the inverse square law of light. Thus, the effectiveness of their communication is often limited by the decreasing intensity of light with the distance. Light can be absorbed and thus brightness varies. Fireflies can only receive responses from others within the visual range of their flash. Can these flashing patterns of fireflies in a group be used in solving real-life problems? In late 2007 and early 2008, the Firefly Algorithm was developed by Xingshen Yang. Xingshen Yang was a senior research scientist at National Physical Laboratory, best known as a developer of various heuristic algorithms for engineering optimization. He obtained a doctorate degree in applied mathematics from Oxford University. He has been on the prestigious list of highly cited researchers by Clarivate Analytics and Web of Science since 2016. His idea for the Firefly algorithm is simple. All fireflies are unisex, so one firefly will be attracted to other fireflies regardless of their sex. A slight variation on the natural attraction pattern exhibited by fireflies. Attractiveness is proportional to a firefly's brightness. Thus, for any two flashing fireflies, the lesser brighter one will move towards the brighter one. The attractiveness is proportional to the brightness, both of which decreases as their distance increases. If there is no brighter one than a particular firefly, it will move randomly. The brightness of a firefly is determined by the landscape of the objective function. The basic pseudocode of a standard Firefly algorithm looks like this. Define f of x to be optimized. It represents the fitness of a firefly's position in the search space, where x is a vector representing the position of the firefly in d-dimensional space. Initialize a population of n fireflies with random positions in the search space. These positions represent potential solutions to the optimization problem. Evaluate the fitness or light intensity of each firefly in the population by applying the objective function f of x to their respective positions x sub I. Set the light absorption coefficient gamma, which is a parameter that determines how quickly the light intensity decreases with distance between fireflies. A higher value of gamma means the attractiveness decreases more rapidly with distance. Begin a loop that continues until the maximum number of generations, that is max generation, is reached. This loop represents the iterative nature of the Firefly algorithm. Initiate an outer loop that iterates over each firefly in the population. Start an inner loop that iterates over each firefly in the population. This loop represents the interaction between fireflies to determine their movement. Check if the light intensity of firefly I, that is L sub I, is less than the light intensity of firefly J, that is L sub J. This comparison determines if firefly I is less fit than firefly J. If firefly I is less fit, that is, it has lower light intensity than firefly J, it will move towards firefly J in the search space. This movement is an attempt to improve the solution by moving towards a more attractive or better firefly. Adjust the attractiveness of firefly I towards firefly J based on the distance r between them. The attractiveness decreases with increasing distance, and the rate of decrease is controlled by the light absorption coefficient gamma. After the movement step, the new positions of fireflies are evaluated using the objective function f of x, and their light intensity is updated accordingly. Rank the fireflies based on their fitness, that is, their light intensity. The firefly with the highest fitness represents the current global best solution G. The algorithm will terminate after reaching the specified number of generations. After the algorithm terminates, further analysis can be performed on the results, such as visualization of the solutions, convergence behavior, and characteristics of the optimal solution. Overall, the Firefly algorithm optimizes the objective function by iteratively moving fireflies towards more attractive ones, and the process continues until the termination condition, that is the maximum generation or other criterion, is met. The result is an improved solution that represents the global best solution found by the algorithm. Since the initial discovery of the Firefly algorithm, a lot of sectors have benefited from it. Nayak J. paper, Firefly Algorithm in Biomedical and Healthcare, Advances, Issues, and Challenges, outline the various ways in which Firefly algorithm has impacted the health sector, from gene selection to cancer classification, medical imaging, breast cancer detection, classification and analysis, heart and brain related issues, etc. This nature-inspired algorithm is making waves in the health sector. Another research titled Application of the Firefly Algorithm for Optimal Production and Demand Forecasting at Selected Industrial Plants by Abdulhadi Altawi, a student of Industrial and Systems Engineering Department, Oakland University, Rochester, USA, proved the use of the Firefly algorithm for determining the product in which the company being surveyed should continue producing to maximize profits. The Firefly algorithm returned amazing results. One major set of characteristics all meta-heuristic algorithms have is the ability to explore and exploit their search space. In the context of optimization algorithms, global search or exploration refers to the ability to explore a wide area of the search space in search of the global optimum, which is the best possible solution across the entire solution space. FA or Firefly algorithm demonstrates good global search capabilities due to its stochastic nature and the inherent exploration of the solution space through Firefly movements. During the iterations, Fireflies move towards more attractive ones based on their light intensity, which is determined by their fitness or objective function value. This movement helps Fireflies spread out across the search space, exploring different regions. By exploring a wide range of solutions, the Firefly algorithm can effectively locate promising regions where the global optimum might be present. Additionally, the light absorption coefficient, gamma, in the algorithm controls the rate of attractiveness decrease with the distance, further aiding the exploration of the entire solution space. Local search or exploitation, on the other hand, refers to the ability of an optimization algorithm to refine or exploit the solutions in the vicinity of the current position. The Firefly algorithm incorporates exploitation implicitly through its iterative nature and the interaction between Fireflies. As Fireflies move towards more attractive ones, they concentrate in promising regions of the search space, which allows for some exploitation of the local neighborhoods. The attractiveness of the Firefly decreases with distance, which leads to stronger interactions and movements towards nearby Fireflies with higher light intensity. This characteristic promotes the convergence of the Fireflies towards local optimal solutions. In summary, the Firefly algorithm strikes a balance between global exploration and local exploitation. It can effectively explore a wide solution space to discover promising regions that might contain the global optimum, while also concentrating solutions around attractive areas for local refinement. Its quality performance in both global and local search makes it a popular and versatile optimization method for various real-world applications. Who would believe that a natural phenomenon such as this can be mimicked and applied in solving real-world problems? Nature has always been a great resource, inspiring groundbreaking inventions. From the invention of the airplane by the Wright brothers to the widespread use of AI systems inspired from the learning process in man. Mimicking natural events or occurrence has always led to major breakthroughs in science and technology. Next, I will be exploring another natural species and see if their behavior can be exploited to solve real-world problems. What do you think about this amazing discovery by Yang? Let me know in the comment section. Endeavor to give this video a thumbs up and subscribe to my channel so that you'll be notified once I upload a video. Thanks for watching, and I will see you next time, my friend.